Now what we'd like to do is understand, since computers only have switches to count with, how do they count? And the reason it's important to understand this is because most of what computers do is about some sort of counting or maths. If we're going to do that, we first need to understand how we count. And the problem with this is we've been doing it for so long we've almost forgotten how it works. This is how it works. We have 10 symbols. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And we use these to count. And we organise them in columns. The first column is units, and we count 1, 2, 3, 4, 5, 6, 7, 8, 9. And we've run out of symbols now. So when we run out of symbols, we put a 1 in the next column, which means it's tens. And then we count 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we run out, we put a 2 in the tens column. And so on and so on. 1, 2, 3, 4, 5, 6, 7, 8, 9. We've run out, a 3 in the tens column. And we continue to do that until this column is full up and this column is full up. And then when we add another one on, we put a 1 in here and change these to 0. And this column is hundreds and this column is thousands. And that's how we work. It's very simple. We've just been using it for so long that we struggle with it a bit to explain it because we're so used to it. Now, a computer is exactly the same, only it doesn't have 10 symbols. A computer only has a switch which can be on or off. And the symbols for off is a 0 and the symbol for an on is a 1. So what happens is the computer starts off with units just like us, and it says 1, and then it looks for the next symbol. It hasn't got another symbol, so it goes 0 and the next column must be 1. Then it says OK, so I'll now add a 1, and then when I add a 1 again I haven't got another symbol, so the next column becomes 1. And I'll draw this out for you in a minute so you'll get it a little bit better. But what you end up with is the first column is units, the second column is 2s, third column is 4s, 8s, 16s, and doubling up those numbers. And what happens now is this. The numbers work like this. That's 0. And let's draw in these other switches, because these are switches. So if you've got a set of 1, 2, 3, 4, 5 switches, if all the switches are set to zeros, that's 0. That first switch is set to 1 and the others are zeros, that's 1. If that switch is set to on and all the others switch to off, that's a 2. If that switch and that switch are turned on and the others are 0, that's 2 plus 1 is 3. Then if that switch is on and all the others are switched off, that's a 4. 5 would be 0, 0, a 4, no 2s and a 1. So you can see how they're using switches, the settings of switches, to equal numbers. That's 0, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. And you can calculate it very easily simply by adding up the value of these columns. So if an 8 switch is turned on and a 4 switch is turned on, that's 8 plus 4, 12. And this process of just having two numbers, 0 and 1, is called binary. So we now know that computers count in binary because they only use switches inside them to count, and the only thing switches can be is 1 or 0, on or off, and that is two things like bicycle, binary.